This is the solution to page 493, so 494, number 10. As we can see here, we have a coordinate plane. This is the x and the y axis, and the center of the circle that's in red here is at the origin. You can also see that we have a 45-degree angle between the x-axis and the radius here that goes to point P. And we're looking for the coordinates at point P. What is the x value? What is the y value? So when we look at the x value and the y value goes horizontally over and the y value goes up to that point P. And so if we were to just, I'm going to draw this out so that I can write on it. Here's point P, here's the radius, and here's that 45-degree angle. So like I said, the x and y value, x is horizontal and y is vertical. And so what ends up happening with this triangle is you end up getting that 45, 90. So the other one using triangle sum has to be 45 as well. And so we have a 45, 45, 90 right triangle. And so if we think about the x and y, these are the legs of this isosceles right triangle. And so if you think about what we learned in this lesson, the shortcut for this special right triangle is leg, leg, leg times the square root of 2. So these are the isosceles legs, and this is the hypotenuse where we take the length of the leg and multiply by the square root of 2. So if we take a look, this is actually what we call a unit circle, and that means that the radius is 1 unit long. And so the radius from the center of the circle to the edge of the circle is from the center of the circle to point P. And so that's going to be the hypotenuse of this right triangle. So my hypotenuse is equal to 1. So the hypotenuse is 1, and the hypotenuse in the ratio is the leg times the square root of 2. So we have the hypotenuse and the hypotenuse in two different perspectives. So we can set up an equation. So we have the length of the leg times the square root of 2 is equal to 1. So the hypotenuse and the hypotenuse, two different perspectives. We want the length of the leg, which is both x and y, so we're going to divide by the square root of 2. And square root of 2 over square root of 2 equals 1. 1 times the length of the leg is the length of the leg. And so our legs are both x and y. So this is equal to x, which is also equal to y. So this would be at the point 1 over square root of 2, 1 over square root of 2, because they're both positive. We move to the right and we move up. Now I'm going to practice rationalizing the denominator so that we can just see that really fast. So we have 1 over the square root of 2. In order to rationalize the denominator, we want to get a perfect square inside of the radical. And so the 2 times 2 is 4. And so what I want to do is I want to multiply by the square root of 2. I think of it as radical parties multiply. But what I do to the bottom, I also have to do to the top so that I'm multiplying by a number equal to 1. Because multiplying by 1 does not change the value, it just changes the look. A lot of what we did with dimensional analysis. So multiplying across the top, I get 1 times the square root of 2 is the square root of 2. And then square root of 2 times square root of 2, that's the square root of 4. And the square root of 4 is 2. And so the coordinates for P are going to be square root of 2 over 2, square root of 2 over 2. Again, both values are positive because we are moving to the right and we are moving up. Right is a positive value, up is a positive value.